Hello, I'm Vincent Philip Vogel, and today, November 21st, 2018, I want to share general relativity's implications for dark matter, dark energy, and the Big Bang. In the next 5 minutes, I'll be revealing a new understanding of these fundamental concepts. Does this look familiar? Objects in mirror are closer than they appear. We are familiar with distorted mirrors, but what about distorted space? Objects in space are larger than they appear. For simplicity, let's call this cosmic compression. Einstein's theory of general relativity reveals that both space and time are distorted in a gravitational field. This is a very well-known and recognized aspect of the universe. We have equations to describe it, and they have been proven through experimentation and the scientific method. I think we can understand that massive objects with strong gravity distort the space around them, but it is important to realize that the space within the objects, including the objects themselves, are also distorted so that they appear smaller than they actually are. We can clearly see the effects of spatial distortion in the obvious case of gravitational lensing. This is an actual image showing how distorted space bends distant light. It is important to realize that the light is bent because the space it travels through is distorted. So since clusters of galaxies are known to severely distort space, and we can see it, what about even a single galaxy? The image on the left is the Andromeda Galaxy as we are used to seeing it. But if we could remove the spatial distortion caused by gravity, the same region of space would look more like the image on the right. When we peer out into space and measure distances based on magnification, I don't think we have been properly accounting for cosmic compression. Now remember, this isn't just a visual distortion, but it is an actual distortion and compression of both space and the matter within it. Because of this, it may prove challenging for us to measure the mass of any galaxy. For how do we know how much it is compressed just by looking at it? It is also important to realize that gravity's effects are cumulative for both space and time. So even though each star and black hole in the galaxy may only compress space a certain amount, when looking at an entire galaxy, we must factor in the cumulative effect. One of the main reasons scientists believe there is dark matter in most galaxies is due to the measured radial velocity of the stars orbiting the galaxy. They seem to be moving much faster than the estimated mass of the galaxy should be able to sustain. Those stars should be flying off into intergalactic space, but they're not. So it is assumed there must be some unaccounted for mass, which is commonly referred to as dark matter. However, by properly accounting for cosmic compression, we can see that not only is the galaxy actually larger than it appears, but there is also much more central mass to support the higher outer rotational speed. Whenever there is cosmic compression, there is also cosmic expansion. This expansion happens between galaxies. The very shape of the universe itself may be distorted by clustered mass, so that whenever we look at distant massive objects, the light is redshifted due to the expanded space and altered time. This is known as gravitational redshift. We know that the light from distant galaxies is redshifted, but it is not because they are receding faster and faster away from us. Rather, it is from the stretched space and distorted time which changes the wavelength of the light. This understanding may be the explanation for what we have been calling dark energy, and it may also mean that there was no Big Bang after all. The current research into dark matter and dark energy may be able to help us know where to look and how to quantify cosmic compression. The Wikipedia page for gravity lists various gravitational anomalies where gravity seems to behave in unexpected ways. I think some of these discrepancies can be explained by properly accounting for spatial distortion. So who can answer these questions? Have astrophysicists been fully accounting for cosmic compression all along? Could cosmic compression be the explanation for dark matter? Does cosmic compression also explain dark energy? And what about the Big Bang? To what degree does gravity distort space and time? How do we accurately measure galactic mass? And if our measurements have been based on size and distance, then we need to reevaluate the calculations once we can properly account for cosmic compression. Please respond in the comments and like this video so it can reach the attention of the astrophysicists who can begin to answer these questions. Thank you.